Hello friends, this is Kiran Patil, working as Assistant Professor in the Department of Computer Science and Engineering, Vijaypura. So, I hope all of you are doing well and wish you health. So in a previous video, we have looked into the introduction of clipping, especially the point clipping. And today, our topic of discussion would be Cohen Sutherland line clipping algorithm. In my previous video, I have already introduced a bit on Cohen Sutherland line clipping algorithm, so I would be quick enough to go through the basics of Cohen Sutherland line clipping algorithm, and after that we shall look into some of the examples. Alright, then let's get started. So Cohen Sutherland line clipping algorithm, basically this algorithm works based on something which is called as region codes. As you can see, these region codes are indicated with 4 bits. The first bit indicates the left, bit number 2 is right, bit 3 bottom, and bit 4 is the top. Now, if you look at this figure, you can easily identify that the region codes are given for the regions that surrounds the clipping window. And the region code for the clipping window would be all zeros, that is 4 zeros. Similarly, the top left corner that lies to the top left corner of the clipping window is given a region code 1001 because of the fact that it lies to the left and it is at the top. So the left bit and the top bit is given a bit 1. We can say the bit is activated for the left and top. Similarly, the region which lies to the left of the clipping window is given the region code as 0001, indicating that only the left bit is activated. Similarly, the bottom left corner or the bottom left region is indicated with the region code 0101. That means only the bottom and the left bit are activated. Similarly, the bottom region that lies towards the or beneath the clipping window is given a code 0100. Only the bottom bit is activated in this case. And then the region which is right bottom is given a region code of 0110, indicating only the right and the bottom bit are activated. And this, the region which lies towards the right side of the clipping window, is given a region code of 0010. That means only the right bit is activated in this case. Similarly, we have a region code for this particular region, which is top right towards the clipping window, is given a region code of 0101, indicating only the right and the top bit are activated. And then the region that is above, exactly above the clipping window, is given the region code of 1000, indicating only the top bit is set to 1. Now, let us look at this example here. Now, how exactly the clipping happens in a Cohen Sutherland line clipping algorithm? So you can see we have a line segment which is indicated by 2 points P1 and P2. Similarly, there is a line segment which is indicated with the point P3 and P4. So in case of P3 and P4, or even in case of P1 and P2, the algorithm works such as: first it clips the left boundary, then it clips with respect to the right boundary, then it clips with respect to the bottom boundary, and then it clips with respect to the top boundary. You can see P3 and P4, when it is clipped from the left boundary, an intersection point will be indicated or will be found out, which is indicated in this case as P3 dash. Similarly, if we talk about the line segment P1 and P2, first the intersection point towards the left boundary is found out, and which is to be P2 dash. Now once this clipping happens, once the clipping happens with respect to the left boundary, then later on the next step would be to clip with respect to the right boundary. As you can see, there are no points or no line segments that lies beyond the right boundary, and hence you can see if this is the right boundary I'm talking about, there is no point that lies outside this particular boundary, and hence we are not supposed to find any of the intersection points with respect to P1 and P2, or even with respect to P3 and P4. Later on, once the clipping happens with respect to the left, then with respect to the right, later on it is with respect to the bottom. So here you can see this is the bottom boundary, and here you can see that there is a point which lies beyond the bottom boundary, and which is the point P1, and hence we are supposed to find an intersection point with respect to the bottom boundary, and that is indicated with the intersection point P1 dash. Similarly, after the clipping happens with respect to the left bottom boundary, at last we are supposed to find out the intersection point with respect to the top boundary, and here in the case there is a point which lies outside this particular top boundary, and that is indicated with the point P2 dash, and hence we are supposed to find out an intersection point with respect to the top boundary, and that is in this case indicated with P2 double dash. Okay. Now here you can see how the clipping happens. You can see this is the line segment indicated by 2 points. The point are represented with x0, y0 and x and y end. First, as you can see, the clipping happens with respect to the left boundary, then it is with respect to the right boundary, and then the bottom, and at last it is the top boundary. So this is the sequence of clipping any line segment with respect to the clipping window. Let me now repeat it once again. First, the clipping happens with respect to the left boundary of the clipping window, and then the right boundary of the clipping window, and then with the bottom boundary of the clipping window, and at last with respect to the top boundary of the clipping window. Now, the next question is, how do you determine the intersection point? How do you find out the y-intercept and the x-intercept of any intersection point? Okay. To determine a boundary intersection for a line segment, we can use a slope-intercept form of the line equation. For a line with endpoints x0, y0 and x and y end, the y-coordinate of the intersection point with a vertical clipping borderline can be obtained with a calculation such as y is equal to y0 plus m into x minus x0, where x value is either set to xw min or xw max, and the slope of the line is calculated as m is equal to difference in y coordinate axis divided by the difference in x coordinate axis, that is nothing but yn minus y2 divided by x n minus x naught. Sorry. Similarly, if we are looking for the intersection with the horizontal border, the x coordinate can be calculated as x is equal to x naught plus y minus y naught divided by m. Now, basically it is to know that how are we supposed to find out the intersection point? How do we know that, uh, what could be the values of x and y for an intersection? So as it is already discussed in these two paras, let me just briefly make you understand what the para is about to say. So here the y intersection value or the y value of the intersection point will be given with an equation y is equal to y naught plus m into x minus x naught, where y naught and x naught are self-explanatory because they are nothing but the end points of the line segment, that is x naught y naught, and then it is x end y end. Okay, where m here is nothing but the slope of the line, slope of a line segment. So as we are already aware with the knowledge of mathematics that any slope is given with an equation where it is the difference in the y coordinate divided by the difference in the x coordinate, so as to say m is equal to yn minus y naught divided by xn minus x naught. And then we can also determine the x value as x is equal to x naught plus y minus y naught divided by m. Here in the first equation, that is equation number 14 as indicated here, the x value can be either set to xwmin or xwmax, because here the only unknown entity in this particular equation, because already we have y naught, we know x naught, m could be calculated, but the one element or one unit which is not yet determined is the x value. So what it says, the x value is either xwmin or xwmax, that is the minimum value of x for the clipping window and the maximum value of x for the clipping window. It can only have two values based on what kind of a clipping you're trying to obtain or what kind of an intersection point you're trying to supposed to find out. So similarly, in this particular equation here, x naught is known, y naught is also known, m can be calculated when we have the two end points. One thing that is not calculated or that is not given or that could not be calculated is y. Again here, y is either ywmin or ywmax. Seems to be y has either the minimum value for the clipping window or the maximum value of the clipping window. Right? In this way you could find out the y coordinate value as well as the x coordinate value for an intersection point. I hope I made clear with the concept of Cohen Sutherland line clipping algorithm. If there are any questions, you can ask me by giving out your messages, and I would make my best efforts to resolve it. But once again, in these hard times, I would suggest, advise all of you to please stay at home, stay safe, wish you health. Thank you very much for watching. Thank you all.